Glucose-6-phosphate dehydrogenase is the rate-limiting step and primary control point of the NADPH generating portion of the hexose monophosphate pathway. Glucose-6-phosphate dehydrogenase is stimulated by NADP and inhibited by NADPH. The levels of glucose-6-phosphate dehydrogenase are increased by insulin. The 6-phosphogluconolactone produced by glucose-6-phosphate dehydrogenase is unstable and will undergo spontaneous hydrolysis. The hydrolase merely accelerates the process. The hydrolase reaction is effectively irreversible under physiological conditions. 6-phosphogluconate dehydrogenase catalyzes the formation of the second NADPH. It has a reaction mechanism similar to that of isocitrate dehydrogenase, and like isocitrate dehydrogenase, yields an unstable product that rapidly decarboxylates to release ribulose 5-phosphate. Due to the loss of carbon dioxide in this step, the 6-phosphogluconate dehydrogenase reaction is irreversible under physiological conditions. The ribulose 5-phosphate formed in the 6-phosphogluconate dehydrogenase reaction acts as a substrate for two different enzymes. The isomerase converts the ketopentase ribulose 5-phosphate to the aldopentose ribose 5-phosphate. The product, ribose 5-phosphate, is the precursor for all nucleotide synthesis, and its production is an important function of the hexose monophosphate pathway. Epimers are carbohydrates with reverse stereochemistry at one of the carbons. Ribulose 5-phosphate epimerase converts ribulose 5-phosphate to its epimer, cellulose 5-phosphate. Transcatalysis is used in two separate reactions in the hexose monophosphate pathway. It transfers 2 carbons from cellulose 5-phosphate to ribulose 5-phosphate to release the 7-carbon acetoheptulose 7-phosphate. Alternatively, it can transfer the 2 carbons to erythrose 4-phosphate to produce fructose 6-phosphate. In both cases, the remaining carbons from the cellulose 5-phosphate are released as glyceraldehyde 3-phosphate. Transaldolase catalyzes a 3-carbon transfer from acetoheptulose 7-phosphate to glyceraldehyde 3-phosphate, leaving erythrose 4-phosphate and forming fructose 6-phosphate. In the case of transaldolase, the covalent intermediate is formed between the substrate and the lysine side chain of the enzyme.